Hello, welcome to The Extraordinary, where we are committed to the relentless pursuit of excellence. If you love tech, you love learning new things, or you just want to skill up, subscribe to the channel so you don't miss any of our content. In today's episode, we are going to be looking at iterators in Python. And by now, you would have noticed that every container object that we've worked with you could loop over it with a for statement. Example, you can loop over a list, you can loop over a dictionary, you can loop over a string, you can loop over a file, the contents of a file. Like, let's see an example, some of these examples. Create a new file, say example 1.py, say for elements in 1, 2, 3, print element. And if we run this, we can see that 1, 2, 3 is printed to the screen. Same thing can be done for a dictionary. Comment this first one out. We have our dictionary here. Say 1 is 1 and 2 is 2. Key is 2, the value is 2, the key is 1, the value is 1. Now we're printing, say for key in this, let's print the key. And what do we have? Hang on. So this semicolon. So this colon. Now let's run this and we get the key 1, 2. For our string, we can do the same thing. Let's comment this one out. We can save or char in a 1, 2, 3. 1, 2, 3 print char. If we run this, we get 1, 2, 3, and we could also do the same thing for a file, but I'm not going to do that. I'll leave that to you as an example. You can try it out yourselves. So basically, you can loop through any container object. This style of access is clear, concise, and convenient, and the use of iterators pervades and unifies Python. Behind the scenes, the for statement calls an iter method on the container object. This function returns an iterator object that defines the method __next __, which accesses elements in the container one at a time. When there are no more elements, the __next __, method raises a stop iteration exception, which tells the for loop to terminate. You can call the __next __, method using the next built-in function, and we can take a look at that example here. So let me create a new file, say example 2.py, and in here I'm going to define a string ABC. Then I'll define an iterable of that string, which is just me calling the iter function on the string that I defined. Now that I've defined this iterable, I can use the next built-in function to call successive next values of the string. So I can call each character one after the other. So let's do that now. So print next it. This is going to print A. Print next it again. This will print B. print next it. Third time, this will print C. And if we call it one more time, next it, this will throw stop iteration exception. Okay, let's see that example. Clear this, do Python example 2, and we see we get A, B, C, and then we get this exception, stop iteration. So now that we've seen the mechanics behind the iterator protocol, it's easy for us to add an iterator behavior to our classes. First, we'll have to define the underscore iter underscore method, which returns an object with underscore next underscore method. Now, if the class defines a underscore next method, then the iter can just return self. So let's see an example of that. In here, we can define a class called reverse.py. If we do that, I can come in here and say class reverse. So say iterator for looping over a sequence backwards, and I'm going to define the init function for this class self data. I'll say self.data is equal to data. So now I'm going to go and do an example for this. So we'll create a new file, example3.py. Here we're going to import the reverse class. So from reverse, import reverse, and here we're going to say rev is equal to reverse span. Now I will try to loop through this. Say for char in rev print char, and if I run this example, what do I get? Let's see, I get an error, and this error says that reverse object is not iterable. Why is that? Because we've not yet defined the underscore iter underscore method and the underscore next underscore methods. So let's go and define those methods now. We're coming here and say def underscore iter self, just return self, and also come in and say, first of all, self.index is equal to len of data. Now def underscore index or next self, and if self.index is equal to 0, then we throw the stop iteration exception. So we raise the stop iteration exception. Otherwise, we say self.index is equal to self.index minus 1, and we return self.data of self.index and save. So what's happening here is when we try to look through this an object of this class, it will call this iter function, and that function is going to return the object itself, which now provides an underscore underscore next underscore underscore method, which will now be called every single time to get the next item in the iteration. What this is doing is it's going to check first, deduct 1 from the index, and we first of all define the index to be the length of whatever data is being passed in while we initialize the iteration, the iterable object, which is an instance of this class. And we are going to deduct that length by 1 first, because we don't want to let it go out of bounds, and we'll assign that value to be the new index. Then we are now going to return the value of the data that is at that index. So that's how this works. Now if we come in here and run this example, we no longer get an error. See, so this allows us to return spam in reverse, like print MAPS. So that's how you create iterators, which are objects that can be looped over. And that's it for this episode. In the next episode, we are going to look at generators. If you enjoyed the content, please like and subscribe and share with your friends, and I'll see you in the next one. Bye.